Okay, welcome everybody. Welcome to the discussion tracking the progress of AI in the RAN. My name is Stefan Pongratz. I'm one of the analysts here at the Dell'Oro Group. We are a US-based market research firm focusing on telecom data and enterprise networks. And we're going to discuss where we are and where we're headed and risks with AI in the RAN. So I think with that, first let's walk around the room here and maybe we can we're fortunate enough, we don't have one, we have four experts here with me. So let's, maybe we can start out with introducing ourselves. Who wants to go first?
I'll go
Hi,
first. Go ahead.
I'm Mike Irizarry. I work for UScellular. I'm the EVP and CTO. Have responsibility for all things network, all things IT, and very happy to be here with this elite group of people.
Rob Hughes with Fujitsu Network Communications, where I focus on a lot of the wireless marketing.
Perfect.
Guy Turgeon with Red Hat, where I'm a senior industry principal on Telco.
Hi, I'm Ofir Zemer. I'm a VP at Qualcomm, and I'm in charge of our RAN automation suite within Qualcomm.
Okay, great. This is perfect. Let's. Now we heard the alliance here discuss a little bit about AI in the RAN. So I thought we could start maybe with kind of just high level. Where are we right now? There's a lot of discussions in terms of we have been doing AI RAN for some time. And there's obviously different definitions of AI in the RAN, but more high level where we are, where we're seeing some potential traction right now. Yeah. Who wants to start with that? And it's fairly open-ended. You can focus in on various parts of it. I know there's different. There are a few technical boundaries here when it comes to AI RAN.
Yeah, happy to start, Stefan. So from Red Hat, from our perspective, what we're seeing and following up what Dr. Choi presented from the AI RAN Alliance, it's a lot about AI ops. And the AI RAN Alliance kind of calls it AI for RAN. So what we're seeing is the application of AI, and we've been using predictive AI in the RAN networks for a while, but now it's the application as well for generative AI to be able to do AI ops, to be able to do closed loop automation. With 5G, with O-RAN, with Open RAN, the RAN has become more software defined. So that's opened up the opportunity to have more of this automation, which will eventually bring us to, the dark knock concept or a lights out knock.
Yeah, I would agree with that, Stefan. I think right now, I think the area that's getting that's moving the fastest at the moment is the AI ops that Guy was talking about. Where you've got other applications used to streamline operations, or other ways of improving performance, finding ways to whether it's power savings or whatever, find ways to reduce cost of the network. Those are fairly easy solutions to implement that don't necessarily cost a lot and require big changes to the network. And so that's what's moving I think the fastest. I think the most potential comes from the more the AI RAN capabilities where you're putting the RAN software directly on the same shared infrastructure as the AI capabilities. They're both RAN software and AI applications on the same hardware, and I think we've got some pioneers that are moving in that direction. SoftBank, T-Mobile, etc., that are making that happen. But that's not yet to the. It's not. Some of the other things like the AI ops things I think are going to happen a little bit faster than that.
Okay,
Sure,
great.
operator.
Okay,
go ahead,
sorry.
Stefan. Yeah, I was going to share an operator perspective. I would say we view it through a couple lenses. One is AI within the RAN architecture, and I would say from that perspective, it's still very early. I think the architecture is taking shape, as well as where it's best applied within the architecture, and that's critically important if you think forward to 6G and perhaps even 5G advanced. And then we think about it as AI on top of our existing architecture, and I would say progress there is moving along briskly. And from our perspective, we're applying it very judiciously. And as was mentioned earlier by my colleagues, we're applying it and analyzing logs coming from the network, security logs, handoff logs. We're also using it for site selection to be more precise. And we're also using it now, working with our vendor partners and optimizing the radio link, particularly on the uplink, the reverse link, which is one of the most challenging aspects of the radio network. And we're seeing some nice improvements, improving edge performance. And then the last thing I'll say is we've been piloting an agnostic platform that's AI ML based that allows us to optimize power consumption by putting to sleep certain carriers on certain cell sites. So I would say things are moving along nicely, but at different paces depending on where you look at the network.
Okay, great.
So maybe I'll add Qualcomm's perspective. So I lead the RAN automation suite. So obviously, by definition, I'm most interested in the AOps aspect. Customers using our automation suite. I have colleagues within Qualcomm that are also looking at the hardware aspects, but that's a topic that I'm less involved in. Within the AI ops, the way that we've been working with our key customers is actually analyzing what the engineers are doing. Because obviously you can use AI, and we are using AI extensively over the last 2 years to improve performance of the network, but that doesn't necessarily save OpEx. When you actually look at some carriers, especially large ones, have an army of engineers crunching KPIs from various systems all day long. That's where really they want us to insert our AI to take that load away. Because if you look at a large carrier that want to reduce its OpEx, and I've heard many numbers thrown around, but let's be conservative. Even 10% for a large carrier, that's a couple of billions in saved OpEx. Then you need to really do a bottom-up analysis of what the engineers are actually doing, and that's how we're inserting both our AI capabilities as well as our generative AI and our AI agents to really replace a lot of the mundane work that engineers are doing on a day-to-day basis. And carriers that have implemented that in North America and in Europe are reaping pretty significant benefits out of that.
Okay. Good. That we see. So we see. It sounds like various activities now, primarily in AI ops, but also starting to see in other areas, especially obviously when it comes to, let's say, power consumption. I think we see various more tangible announcements across the world in terms of actual real benefits of integrating AI and RAN. And then, of course, anything that we can do to reduce OpEx, we see that as a lot of efforts in that arena right now. If we look to a little bit more into the future, we see both near term and long term, and think about how AI and RAN can work together. Do you see that the value proposition, I guess, changes a little bit? We will see a shift, or where do you think there will be more value, I guess, overall when we look at the broader vision long term? It could be in the same places as well that we've just discussed as well.
Yeah, maybe continue. So this would be the AI on RAN. This would definitely be the future. I mean, it's not new. I mean, we spoke about AI on RAN from the perspective of MEC, right? So when 5G came along, we're all talking about AR, VR, and having these edge compute, right? But AI on RAN is essentially that, and so where the industry is going, and that's where really I think operators would be looking to monetize, where you're going to have this real-time inferencing, and they'll be able to leverage this large distributed network that frankly, hyperscalers should be very envious of. So if they can roll out the infrastructure properly, have these edge resources, then there is opportunities for operators to monetize that. And then with the AI and RAN, I think that's more of an area where we will see where the adoption happens within the RAN network. So right now we're seeing strong push from the likes of the NVIDIA, where they're providing these platforms, which maybe a little overkill for today in terms of delivering, RAN forward error correction, L1. Uh, but the hope is that all this extra GPU and capacity that you roll out at the edge of the network will be able to be leveraged, and you'll be able to run your AI and RAN, your AI workloads. And that's going to require, from our perspective, a very, very open, configurable, software-defined platform where you'll need to do all this workload scheduling across your entire network. So I think with the direction and the adoption of AI, we're moving to a model where you will have to adopt cloud native principle, more open platforms for your RAN infrastructure, and not be in a position where you can just adopt appliances as we've seen with 5G.
Stefan, I think that right now we're in a, as some of the things that Mike pointed out, that we're focused on things like optimizing our power consumption. There's things that we're doing with using AI/ML to aid in troubleshooting multi-vendor networks, etc. And that's the low-hanging fruit that's easy to go after right now. I think when we start moving towards, I think the ultimate dream that people want to get to is launching some of the new services that Guy was talking about, that can bring in some new revenue to help pay for all of this. But it's, as we've seen many times before in the past, it's sort of a chicken and egg kind of situation. No one wants to develop applications until the infrastructure's there, and no one wants to deploy the infrastructure until the applications are there. And I think one of the ways to get through that is to look at the fact that, hey, these GPUs are valuable assets that people really want to take advantage of. And there's an opportunity to monetize the excess capacity that is in the network. So through open AI APIs, you can make that capacity available to third parties. And that really de-risks the investment for the operator, because they can get started now. They can use those GPU resources to do some of the AI things to improve RF performance or performance of the network, get those advantages, and then as new services become available, they can take advantage of those. But in the meantime, you're not sitting on an asset that's just collecting dust. You're using it to generate new revenue.
And
could
Rob,
build
you get
on
a
that.
sense?
Oh, go ahead, Stefan. Yep.
Yes, I was going to, Rob, you get a sense that operators are because you meet with multiple different operators that they're buying into this vision.
I think most operators are focused. I'd like to hear Mike's opinion, but what I think most folks are primarily focused right now on how can we use AI to improve the RAN and RF performance. But I think if you're looking at start looking at the dollars and cents, you need to find a way of doing more than that. And I think that's the long-term vision. I think that was the point of your question, is where are we now versus the future? Long term, you got to find ways of making money with it. And so I think that's where I think people are thinking longer term. But people, we're all engineers. We've all grown up around RF environments, and that's the first thing that we want to look at is, how do I use this to improve my network? But I'd be curious to hear Mike's view.
Yeah, I was gonna validate what Rob, the picture Rob painted. I agree completely. Like, the whole concept of ORAN and Open RAN is, this disaggregated network with different vendors, a more robust ecosystem, but with that comes complexity, and you just can't scale people to support that. Which goes back to what Ofir said earlier. The goal isn't to lay people off or reduce people. It's to, minimize the number of people you add to support this scaling complex networks. So that's number one. And we see that now where we're applying AI and ML to help. The second area I'm really excited about is one of the challenges we have in the United States, but I think it's not just in the United States, is potentially not enough spectrum to support the traffic growth that we're seeing from things like FWA and sensorization, across many different domains. And so we're looking for ways to get more out of our existing spectrum assets, so specifically spectral efficiency. So one of the things that work is going on now, which we're really excited about, is actually moving away from conventional algorithms that handle the mapping and demapping and channel state information from the radio environment and letting AI do its thing, because there's a lot of uncertainty with that data that only AI can pull out. And we think, we could see anywhere from 10 to 15% improvement in spectral efficiency in the early stages by applying that. And that's goes right to the bottom line for us. So that's one that we're really excited about. The other one is slicing. We have 5G core deployed. I would say it's still very early in its adoption. We're using it right now to separate FWA, which is a very demanding use case, from mobility. But I think AI can help manage slices, and we're looking to see that as well. So it's very exciting, early stage, different trajectories for different areas, but all headed in the right direction.
That's great. But the bottom line is that at least for now, you're seeing at least 10 to 15% of feedback with the AI helping with the CSI. Yeah. So that's great feedback information. Sorry, go ahead.
No, great, Stefan. With the caveat that again, sprinkling GPUs within a RAN network is not the area that I'm in charge of. Honestly, I struggle to see who foots the bill for that. And I think AI and RAN is a layered approach. So currently, most of our customers are focused on cut costs, and embedding GPUs doesn't cut costs. It does something completely different. And the next thing they want to do, and Mike touched on that, is using AI in order to do intelligent new services. So Mike mentioned two of them that our customers are using, both AI-fueled slicing as well as FWA. You don't need GPUs for that, right? And only when carriers will be able to cut costs very significantly and generate new revenue streams, then I see the possibility that they'll start investing in turning their RAN into a hyperscaler with GPUs. I honestly don't see that happening anytime soon.
I think you bring up a good point. I think everyone needs to be concerned about costs, and especially when it comes to deploying hardware throughout the network. But I think there's opportunities, just like we've seen with other new technologies that get introduced into RAN networks, to start small and then grow. So it doesn't mean you necessarily have to do something and cover the entire network day one. You could start off going after enterprise applications, so you limit the amount of investment that you're doing at the very beginning. Focus on growing a couple of enterprises where you perhaps have a more clear business case and a clear example of the value that you're providing. And once you've got several of those together, maybe then you start to add an overlay and it gradually grows. I think, it was sort of the same way in which 5GSA has evolved in many operators. Some people went and did SA everywhere, but other people were more likely to start with pockets and then grow it. And I think this will be the same thing. It doesn't mean go and change your entire network day one. You can ease into it and go more gradually.
Yeah, I'd agree with that. I buy that vision.
Okay, good. That was a good review of separating where we are now versus where we're headed, and we have mostly consensus there and where we're headed. But I would agree that there's, because I've been speaking with a lot of people when it comes to the long-term vision of AI RAN and the likelihood of their turning into profit centers. And there's definitely more skepticism with that, but more strong consensus about the spectral efficiency and the CSI, etc. Gains for now. Good. So I'm looking at the clock here and some of the questions coming in. I think the next topic would be, I think we're going to jump to the transition here from RAN to AI RAN. How is this going to happen? I guess how do you see this happening? Is it because there are different ways, we like Ofir made a mention, like we actually see already AI RAN happening today, and in many cases they're not deploying new hardware. We see actually the majority, I would say, of these some of these announcements when it comes to power savings management and things like that, we see them being deployed on existing infrastructure via software upgrades, etc. So why don't we just leave it fairly open-ended and how we see this transition happening from RAN to AI RAN? If it's more with 5G, or is it more a step function with 6G, or yeah.
I'll go again. Maybe this last time. I think, the transition is an evolution, but I think it's going to be very specific to the operators. So some operators have moved towards more of a cloud-native, software-defined RAN network. So from that perspective, they're in a good position to be able to deploy new workloads. They've also leveraged COTS hardware for their RAN network. And now in that COTS hardware, they can go off and they can add GPU capabilities. So they already have a very configurable software-defined using COTS hardware RAN network that will bring them to 6G and will enable them to have this evolution to more AI capabilities. But then we have the other model, which is still appliance-based. So from that perspective, these operators are going to be more in a forklift upgrade, right? Where it will be a much more involved upgrade. Their skill sets internally will be there'll be a large learning process for them to know how to configure, manage, lifecycle these platforms that are capable of hosting these multi-vendor environments and to be able to host AI workloads. AI workloads essentially are just like regular software-defined workloads that need to be scheduled. If those skill sets for lifecycling management haven't been brought into the organization, then it's going to be a very difficult transition.
Okay, great. Anyone else want to chime in?
Yeah, maybe I'll go next.
Go ahead.
We'll break
go ahead. Yeah, go ahead.
If I generalize, I look at our customers around the world, who's more adaptive to AI and gung-ho on introducing, and again, our version of AI is really on the AI ops. I would categorize them as highly OpEx stressed carriers that are not under MS management. That's the common denominator. Okay, so these are carriers that, in some respects, really want to cut down on their OpEx as quickly as possible, but they don't have a managed service deal with the likes of Huawei or somebody else, because then things are a bit tricky, because it's a managed service deal and somebody else that runs the network. If I look at those are the guys that are already, for the last year or two, are really deploying AI heavily and counting the dollars, saying, okay, I want this capability. How much money does it save me? And they're really working that way.
Yeah, that makes sense. Go ahead.
Yeah,
Yeah,
I would add, just going
go ahead,
back
Mike.
to what Rob said, for us, it's not going to be a rip and replace. as Ofir said, we're in a very competitive industry, which puts a lot of pressure on margins. So whatever we do will be guided by the return. So as we life cycle different components of the network, we'll ask our partners to make sure it's cloud ready, it's AI enabled, and then we'll make our decision based on performance and economics. Not averse to appliance-based solution. My preference is something that's not, but it has to give a return that's meaningful, but it'll be piece by piece within the network. I doubt that we'll take a rip and replace, and I view 6G very similarly, which is supposed to be AI native, and some of the standards organizations, carriers have jumped in and said, we're not going to do a rip and replace. We want it to be more evolutionary. But I think taking that approach allows for minimal disruption to the customer. It allows what Guy mentioned as a concern, bring your team up to speed to support that transition, but it'll be evolutionary rather than rip and replace.
Okay, yeah, great. I would just add the the idea you spoke about 6G. 6G creates it's a natural time to change out the network when you're already up changing hardware, etc. I also agree with Guy's point that it really does depend on where the operator is coming from. So if there are some operators who are already independently building out AI factories, for them, creating accepting AI RAN into the network it makes an easier business case. For operators that already have a fair amount of centralized RAN, it's easier to pool GPU resources in that area. So going into the idea of monetizing excess capacity in the network is easier in a CRAN environment. It's not that you can't do things with a distributed RAN, but in a DRAN environment, you're probably going to be looking more at RF performance improvements and perhaps new services. It will be easier to do there. So different operators are going to go at different paces depending on what assets they have in the network and where they're coming from. But that's all talking about the AI RAN, where we're having AI and RAN software on the same hardware. Many of the things Mike pointed out earlier, whether it's power savings or troubleshooting or some of the other AI ops things, those are easy to do right now today without huge investments.
Okay, great. I'm looking at some of the questions coming in here, and I think we have time to backtrack slightly here when it comes to AI RAN in terms of the role for the broader automation journey here. If we look at I think, so maybe dig a little bit deeper on that one. I think if we look at the TM forums, I guess definitions between completely manual and completely automated, I guess the operators are mostly on the between level 1 and level 2. I think that is what they said. So some assisted, but it's pretty far from level 4, level 5 autonomy. So I guess just very quickly, and I guess how important is this AI RAN in this broader journey towards automation here? If we can touch on that quickly, yeah.
So if I might begin, so we identified that if you analyze and I think the mental structure that TM4 put around this is very helpful, and carriers indeed relate to that. And when you analyze what it takes to move, now by the way, I believe most carriers will claim they're between 2 and 3, not between 1 and 2. But regardless,
I agree. I'm 1 and 2.
Okay. But most carriers will claim that they're between 2 and 3, and I'm not in a position to argue with them. But they're really interested to move to 3 or to 4 and eventually to 5. If you look at that jump between 3 and 4, it's all about automated decision making and automated analysis. And that's something that any carrier, even smallish carriers, the amount of data and the complexity and the amount of systems that generate the data all the way from probes and logs and traces and what have you, It just cannot be done without a very robust layer of AI agents. So we believe that in order to move from 2 to 3, but definitely above 3, you need a very powerful AI agentic layer in order to allow automated analysis and automated decision making. Without that, carriers can do a great job on a lot of other stuff, but they will not be able to progress above layer 3, in my view.
Yeah, I agree with that. AI it's the brains, and it's absolutely required, right? We need to move beyond just these simple scripts and this automation that we have today, and go to have a more predictive and be able to take, generative AI, right? These LLMs today, they're really good at reasoning. They think, and I don't think that's what they was originally built for, but their reasoning is incredible. So when you mix that with the information that we get from the network, the predictive information that other AI models can create, then you can get some very advanced automation. I don't think we'll be able to achieve that without AI.
Great. Okay, then let's. So we've talked about where we are, where we're headed, importance of AI in the broader automation journey here, and a little bit about the transition. I'm wondering if we can touch on where we think it will make more sense in terms of implementing it, and obviously from automation, it will touch on everything. But I'm talking here about if do we see it more as, let's say, more of a distributor centralized? Is it more like Rob was talking about, maybe a more enterprise focus versus the larger macro grid, or is it massive MIMO? Or and we've touched on the single purpose versus multi-purpose tendency as well. I gather it's more single for now, and then possible multi-purpose tendency in the future. But yeah, I want to see if we can touch on a little bit where you see it might make more sense to introduce AI RAN, I guess. Yeah. Mike, you wanna
Yeah,
try?
happy to. I'll go back to what I said earlier. I think our application of it will be guided by where there's a clear return.
Yeah.
Improving cost, hopefully at some point revenue, maybe by differentiating traffic and offering that as a unique service to customers, based on their profile. But that's how we're going to be guided by the application of it. Now, when I think about our main challenge of concerns around spectrum availability, I'm clearly going to look at, is there something available to deploy within the architecture that improves MIMO scheduling? Right now, that's not AI enabled, but there's a lot of promise that will improve beamforming, beam adjustment, all those things that allow you to get a lot more out of your spectrum. So we'll look to deploy it there, and that will drive architecture decisions. Do I put it on a virtualized open platform, or do I work with a partner that has an appliance that is much more power efficient and offers more spectral efficiency than a more generic open platform? We'll be guided by performance and cost and manageability. And then I agree with what Ofir said. We can apply the scripts in places in terms of managing the network and optimizing it, but you really need to be thinking about this agentic layer, which to me is really, really early in its infancy. If you go back to Mobile World Congress, it just started to get attention there, and now there are vendors offering solutions for that. But until we feel there's something there that we can just put in and allow that across the network, we're going to be guided by the returns, improvement in customer experience, both in operational management, customer service, and where those things intersect. So that'll be our compass for how we deploy AI and ML within the network.
Thank you. That's great feedback.
One thing I might add, Stefan, is I think, yeah, beamforming has some unique things that you can do with AI RAN for it, but otherwise, small cells, macros, I'm not sure that it makes a big difference. We already spoke about some of the advantages that CRAN might have for people that have CRAN or if they have AI factories. But I think one thing that's worth people keeping in mind is once you've got some AI RAN in the network, you'll be able to do some of the RF performance improvements like Mike was talking about, or whether it's things we've been working on to improve uplink throughput and what have you. And the fear is if you don't get started, what does that mean? The competition will start gradually improving and getting these performance benefits. And if operators are not taking advantage of those things, they risk being left behind. And so there's also a danger in not doing anything as well.
That is true. Okay, good. Anyone else? Or I'm looking at, see, we don't have too much time here left. I think let's do one just high level on the risk. We've talked about some of the opportunities here, but what do you see the main factors impacting the RAN to AI RAN transition, both from the OpEx vision and this AI on RAN, with AI being a potential revenue booster for the operators as well? Yeah. What do you see potential risk, both on the upside and on the downside as well?
Yeah, maybe I'll begin. There's a point that we're seeing with our carriers, and eventually, when you put AI in order to automate the analysis and eventually automate the decision making, you run into some of the problems that AI already shows in other domains of hallucination, etc. What we see, I wouldn't necessarily call it a risk, but it's something that you really need to be aware of and work hand in hand with the carrier. You need to implement it in a gradual way that the carrier executive team, like the Mikes of the world and other carriers, will really gain trust that this won't bring their network tumbling down, right? Because then the whole thing doesn't make sense. And again, it's not a risk per se, but it's not something that you can expect to put in a network, turn on the switch. Nobody in Mike's position will trust that on day one, and I wouldn't if I were there.
Yeah, I would add. I mean, you're absolutely right for that. That's not how we would approach it. But in addition to that, there are two risks that I think about. One is the security risk. For all the AI, particularly AI on top, you need a lot of data. The more data, the better the performance of the model, and ongoing tuning. And so you need to make sure you've got the right architecture, practices, policies, and expertise to secure all this data, because some of it's customer data. And how do you protect that so that your reputation isn't damaged? So that is one. And then the second one is just the infrastructure to allow that data to flow smoothly and be ingested by the different aspects of AI, whether it's the agentic layer or the actual inference engines. We talk a lot about those aspects of AI, but you want to make sure you don't forget it feeds on data, and that apparatus has to be in place and it has to be highly reliable to support that. I'll give you an example. We have a marketing platform. It's a personalization engine. It's driven by AI and it consumes a ton of data in real time. When we first put that in, we didn't give a lot of attention to the data lake and the river that's feeding into that. And when that would go down, because it wasn't designed to the same level of reliability, that marketing platform would stop functioning. We couldn't make offers to the customers in real time. So we had to go back and re-engineer that, re-architect that lake and river to meet the same reliability standards. And I would say that's a concern and a risk that needs to be tended to as you start to deploy more and more AI throughout your system and your network.
Okay, great. Thank you. I'm seeing some pings here. We need to wrap up. So sorry that not everybody was able to answer that last question, but this has been a great discussion on where we are, where we're headed, and some of the risks. Thank you, thank you for all the experts for sharing your insights. And I will now hand it back. Thanks so much, everybody. Enjoy the rest of your day.
You too.
Thank you.
Thank you.
Appreciate it.
Thank you.